Altivar Drives Basics Briefing. This document is an introduction to the Altivar Drives offer. You will see what is a variable speed drive, how to bypass some constraints, and finally you'll have a quiz to assess your understanding of this training. What is a variable speed drive? To see rapidly and very simply what is inside a drive, on an electrical point of view. The drive is made of a power part and a control part where all application I and O are connected: start, stop, reverse, speed and other functions in relation with the application. Core of drive is embedded power electronic. The rectifier, made of 6 diodes, allows conversion AC power to DC power. The filter section is supplied by the rectified voltage. It smooths the waveform according to capacitor actions. Smoother is the DC bus, better is the signal output of the drive. Result will give accurate motor control and torque stability. The inverter is supplied by the DC bus. It transforms DC voltage to AC voltage. It's possible to control the voltage and frequency of the motor signal. The energy is coming from electrical supply and according to the regulation system will be transferred to motor. The motor is transforming electric signal into speed and torque. A drive can convert a fixed input signal in a frequency and voltage variable signal applied to the motor. Application examples. Electrical motors are everywhere, in residential, building, and process sectors. Regarding industrial sector, from the material handling up to the process, it is possible also to enter into complex machine automatism. The way to use a drive can be done differently if this is considered as a simple actuator of if it is used with those integrated functions. Let us take an example of a crane. When the crane is loaded, at the moment start is required, there is a braking function enabling the motor brake to open at the right time to ensure movement will be fluid. This function, braking logic, is embedded and can be managed totally by the drive. This is an equivalent of your handbrake management with a car. Several examples can be taken as our drives embed lots of functions for applications. Those example of applications, you imagine as a visible part of the iceberg. The process point of view will be highlighted with our last range of service-oriented drive, the Altivar process. You will discover meaning of this wording as well as new product simplicity with the multitude of embedded services for our customers. This new range of products had been developed according to customers' requirements. They have been involved very early in the project. You will see that on the second part with ATV6XX and ATV9XX. What are the most common motors? Many types of electrical motors exist. We are not talking on DC motors, old-fashioned. They are less and less used because several reasons including higher maintenance level. Otherwise, the efficiency of motors is an important point. Objective of the 2 following slides is to show the principle of very common motors. Asynchronous motors, and synchronous motors arriving on the market, according to its good efficiency. Today the most part of applications is still done with asynchronous, but future trend will improve the synchronous part of motor. Let us discover the differences between those 2 motors in order to help you to better understand some customers' comments. Basics on motor. How asynchronous motors work. How synchronous motors work. Advantages of using variable speed drives. That would be a long time to have a complete overview of advantages when using drives. Here is an example of what is possible to perform according to drives usage. Let us see an example of energy management. Reduced operating costs. Drives benefits with pumps and fans. The fan's power curve, conventional. The fan's power curve, variable speed drive. Key points to remember. Drives are used in many applications: building, machine, process, etc. Drives allow motor speed management and protection of applications. Drives allow energy savings and energy management. Drives have many embedded functions. Electrical motors are more high-efficiency oriented. How to bypass some constraints? Customer needs are to manage application without taking care on how it is done. Our experience in drives will give the solution in order to meet those requirements. Those phenomena are due to electrical signals. There are adapted solutions to ensure proper management of the motor and make drive fully transparent, allowing to ensure its original behavior. Make the application running properly, efficiently, and as a sustainable way. Introduction to EMC. The EMC is divided in two parts linked to the related frequencies. Low frequencies represents the harmonics, and high frequencies represents the radio frequencies interferences. Harmonics are mentioned in voltage as well as current. EMC will be treated on both the emitted and the conducted ways. Radio frequency interferences. There is no radiation without conduction. These perturbations are existing on both sides, drive input and motor side. What are harmonics? Why be concerned about harmonics? Thank you.